Hello everyone, my name is Aydın Emre Güzel. I'm your head TA. In this semester, we will do our Microprocessors lab together. I'm recording this video for preparation of lab 1. Now you are looking a pre-lab assignment from previous year. In this video, I'm going to solve this pre-lab assignment for you. Please watch the video carefully and repeat the things the things in the video on your own. It's a good exercise for the lab one. The main aim of this video make you to familiarize with using very simple CPU ISS and start to write coding in very simple CPU assembly language. Fatih Hoca, Professor Fatih Hoca teach these things in the lecture also in more details. I just want to do a quick overview and I'm going to write a simple program using very simple CPU and simulate this using very simple CPU ISS, which is a simulation model. I put these files to the LMS also. You can also do the things, the same things with me. And please do these things, and use this ISS with simple program before coming to lab. So in this assignment, in this pre-lab assignment from previous year, the aim is finding the maximum of two numbers. The numbers are located in address 100 and address 101, and write the results, which is the maximum of two numbers, in address 110. It's just that simple. So before starting the implement, let's do a quick overview about the very simple CPU architecture. So this is a readme for instruction set. You can look at this readme from here after download this folder from LMS. The very simple CPU instructions consist of 32 bits. The first 3 bits are opcodes. This opcode says which operation going to be executed, and next bit for immediate. Immediate is for switching the second address to the immediate version instead of an address, instead of a pointer. Then the next 14 bits, 14 bits address 1, and the last 14 bit is address B. Okay, so for writing a very simple CPU instruction, first we have to write opcodes, and we decide if E is 1, put an additional E after the opcode. Then we have to write A and B, which are the addresses or immediate B. For example, let's examine this add operations, add and add E. So add operation is taking the address A and address B, summing them up, and write result to address A. And if you look at the add immediate, it's for the summing of address A plus literal B, and put the result to the address A. So be careful about this notation. So if you see the star and number, star and A and B, this means the address location. This means that this is a pointer. This means that A is a pointer, and star A means the content inside that address. And if you see a single A and B, this means the literal of this number. Okay, for example, if you see something like that, add 40 and 41. This means take the address 40 and 41, sum them up and put the result to 40. If you see like at E 40 and 41, this means take the content of address 40 and put this number with directly 41 instead of the address 41. Okay. So we will talk about in the details in the lab sessions, but the important thing is to not confuse them. Okay. So let's look at our this assignment. For the implementing these assignments, we give you some codes, some high-level C codes. This is a C version of the task. So finding the maximum of two numbers. First, copy the first number to max, and if the first number is less than b, this means this first number is not the maximum anymore. Then the copy second number. If this assignment is false, which means a is the maximum number, and do not execute this line, and a stays max. Okay. So here the prelab low.c, this is the low-level version of this code, which means that every line of this low-level C code corresponds a very simple CPU instruction. So for example, here, this line, this is a simple copy instruction. For example, this is a less than of instruction. This is an BZJ, branch zero jump instruction. You can check them from check the instructions contents. For example, this operations can see directly the same way. So to interpret this high-level codes with very simple CPU, we convert this if statements with this way. So we are doing things like that because we have branch zero jump instruction. Okay. Also, we can talk about details in the lecture. I'm not going into detail now. I want this a short video. So we have to convert. We can easily convert these lines into very simple CPU instructions, and also this is also here. Sorry, not this one. I think I lost it, and let's write it from scratch. So we are starting from address 0. So be careful that every when you start the execution, when you start simulation, so the address 0 is the starting of the first executed line. So your execution start from address 0. So you have to write to start from address 0. Let's convert this low-level C to very simple CPU assembly line by line. This is the max equals A. This is a basic copy operation. Here, let's copy B pointer to A pointer. Let's write copy. So max is 110 and A is 100. So here we are using a temporary value. We can pick any place. So let's pick address 50. And here we are using a less than operation to column space. Do not forget the space after putting column. Otherwise, our ISS couldn't parse it. Less than. TMP is 50. P is 101. BZJ. It's 3. BZJ. Let's put a dash temporarily. Then TMP. TMP is 50. Let's be sure it's. We check P pointer equals 0. If it is equals, jump to A. Here, the notation is in the notation this PC. It's abbreviation of program counter, which says what is the next operation we're going to execute. Okay, so if P equals 0, so the program counter jump to A pointer. Otherwise, it's going to increment by 1 as natural. So now I don't know where to jump, so I put a dash. I will fill it later. And let's put it address in the address 4. We do this operation. It's like a copy. 110 and 101. And this is my AND. So here, for the finish the program, we are doing an infinite loop, which is jump to itself. Like here's the AND. It's like go to AND. So for doing this kind of unconditional jump, we are using BZJI, and let's in the BZJ, let's check it. It's jumping to A pointer plus B, A pointer plus B literal, like puts 0 as literal. Okay. So here for the address 3, we're going to jump this line. So we're going to skip this execution. Then this execution is address 4. So we have to skip this. We have to jump to 5. So this should be 5. But however, this is working with A pointer, not A. So I couldn't write 5 here like that. I have to write an address, for example. Let's select the empty one. Let's select 20. And I put 5 inside 20. And also same thing also valid here, because both going to AND. So this should be also 50. Okay, this is important. This is a common mistake. BDJ works with pointer A, not A. So you have to write an address which contains the jump address like that. Okay. So let's type our numbers. Let's set them, say 30 and 31. Okay. And one important thing is put an additional line end of the program. It's a ISS. It's a simulator bug. Please put an additional line at the end, and let's save it to the folder, the same folder with the very simple CPU executive. Let's name it prelab.asm. Okay, we save this. same folder. Let's execute it. For this very simple CPU executive is our simulator. For use this, we have to use PowerShell or console or command line, because it's not a this is a console application. It's not this very simple exe do not have any GUI. So for the PowerShell, you can type like cmd and browse to this folder, or you can use PowerShell like PowerShell from directly here. So I'm using PowerShell version here. To open PowerShell, press Shift and right click. Then you can observe open PowerShell window here. Now PowerShell opened in this directory. Now let's call the very simple CPU dot slash very. You can type it, or you can using tab after type the first letters. After write the first letters, it's completely automatically. It's very simple CPU executive. I'm putting one blank. Then I'm writing prelab.asm and R. It's the abbreviation of run. I press enter. Let's make it full screen. Now the executor working. So here you can it's printing all the stuff, all the memory operations. Print instruction by instruction. For example, in address 0, it's executed CP 110 and 100, and this is a copy operation, the copying 100 to 110. Now before the execution, 100 is 30, 110 is 0. After, both is 30. Okay, you can also debug your code from here. And at the end, you have to put right exit. It says exiting. We are putting this exit to break the infinite loop, because we finished the program with infinite loop. Here, this address 5, this PZJ completely jump into the address 5. So we write exit. Now, let's observe our program is true or not. So we can see this here, but here in this video I also introduced the files, the very simple CPU ISS using. So this is the file. We write the codes. This very simple CPU executive and this library files is default. So the rest of the files are intermediate files. So this 2.1, so memory out D and memory out D, shows us the memory situation after the execution. So difference between these files are, one of them, D version shows the memory content in decimal, hash version shows the memory content in hexadecimal. Let's look at the hexadecimal one. So our numbers are 30 and 31. The maximum of these two numbers is 31, and we see 31 is in the address 110. Let's change the code. Let's switch the numbers and let's save it. Let's try this version. Okay, reload it. Yes, still 31. We switch numbers and still copy the correct version to the 110. This means our program is working. In this video, I write a very simple program using very simple CPU assembly and simulate this program using very simple CPU executive. And also I show you the execution, the steps, and I do for you a little introduction. In lab session, I will answer your questions, and we will go more in details also in the lectures. For further go in details. So thank you for the watching. See you in the lab.